Okay, so welcome everybody. Nice to have a full room here today. My name is Kreuzer. I'm working for Deutsche Telekom and I like to call myself a smart home enthusiast. So I started really when I was a little boy already automating my room and doing some contacts on the door that music went playing and stuff like that. So I do that all my life already, and I'm actually involved now in 3 different projects around smart home, which you see here are up at the top. The oldest one, openHAB, the Open Home Automation Bus. Another one at the Eclipse Foundation, Eclipse SmartHome, as a smart home framework. And in my day job, by now, I'm working, as I said, for Deutsche Telekom on a smart home platform called KiwiCon. And I somehow managed to get all these things into one. So I'm more or less working on one thing, but for all these 3 projects, which is really cool. So who of you would say from himself that he's already living in a smart home? Okay, just a very few. And who would like to get started? Okay, very good. And what do the others do here? Okay, looking for a quiet room. Well, so if you want to get started with a smart home, then very often you just find some nice gadget for your iPhone, maybe like a smart plug, which you buy in a shop somewhere, plug it in your socket at home, plug in your toaster into it, and are happy that you now have an iPhone app where you can control your toaster, turn it on and off wherever you are in the world, right? Might not be really sensible. You might do more clever things with that, but you like the idea, and so you have some introduction to that. You go ahead and buy some more devices. Is it actually the aspect ratio doesn't look right, huh? So if you know the devices in a different shape, then that's due to the projector here. You buy some more devices, have some more apps on your smartphone for that. And you go on and on, buy more and more, and you end up with a whole lot of devices and a whole lot of applications. But what you didn't end up with is a really smart home, although you have bought so many smart devices. You might see the problem directly on the right-hand side of the screen here, because the smart part is yourself. Because you have all these nice apps which work fine for themselves. Well, there is no interaction between all this stuff. Smart should mean that there is some automation, that it's happening automatically, but it's actually you who gets some notification from the one app and then triggers something else on another. And that's really not a good situation. And from my personal point of view, what's really worse about it is this here. What do the devices do? Every single one of them, or at least every system, does an internet connection to some weird cloud service, maybe in Taiwan or NSA headquarters or wherever, pushing all your data there, waiting for this cloud server to get commands from that and doing whatever the service tells him. Not that you're losing more or less all your data and it's distributed all over the internet. It's also that many manufacturers who did in the past more or less electronics, hardware and so on, they have no clue about building a secure web infrastructure. So every potential connection here could also be a vulnerability for your home and possible security risk. So as all your devices are locally at home, on your local network and so on, wouldn't it be a much better solution to have them also locally communicating, keeping the data local? And as there's no standard yet which would allow such devices to talk peer-to-peer to each other and understand each other, and I think also in 5 to 10 years we won't see such one standard that would make that possible. You need some central point which does more or less the translation between the devices and which integrates all the diversity which is out there in form of protocols and so on. And even if there were one protocol which would allow peer-to-peer communication, you still need some central part which keeps overarching logic, so more or less the really smartness about your home. Shouldn't be distributed in all the different things, but you need to maintain that in one place, and that should also be the one where you have your connection to the internet to remotely get into your home for things. And well, such a device as a central integration point is usually called a home gateway. And the Eclipse SmartHome project is a project that delivers a part of a software stack as a kind of framework for building such home gateways. Now, on such a home gateway, you usually have some operating system, often a Linux version. Eclipse SmartHome then requires a JVM or Java 7 at least. It's using OSGI for modularity to have that as a very modular framework altogether, that you can pick pieces and add things on top that you might need. And Eclipse SmartHome itself is more or less just a set of OSGI bundles then that provide different kind of services, functionalities. And it's not something that an end user would use. So that's where the other two projects come into play. So openHAB, the Open Home Automation Bus, is an open source, freely available solution that you as a user can simply download, install, and run it to build such a gateway, for example, on a Raspberry Pi, BeagleBone, or wherever. And besides openHAB, there can be also other solutions like KiwiCon that we develop at Deutsche Telekom, which is a commercial solution which is directly installed on hardware. The hardware is sold in a shop that you can buy and which is remotely provisioned and so on. And there are also other companies building on the same software stack. Now, what are these services in Eclipse SmartHome? Well, it starts at the very core with a simple domain model for the smart home, defining some core concepts, defining events around this model. And based on this model and the events, there are then mainly 4 categories of services. One is all about connectivity. So getting out to all the different protocol systems, devices, and so on, doing the translation to them. Providing a uniform way of accessing the system through a REST API, for example, so that you, when you come from the outside, do not have to care about all the different specialities of the devices. Next, of course, automation aspect, so to get things automatically working through rules, and they're also being able to put things together as modules. Third, user interface aspect. So instead of having 20 different apps with all a different style and interaction and user experience, it's much nicer to have a single application with one way to access your whole home. And last but not least, all about persistence, so defining what kind of data you want to store, where you want to push it, if you want to push it to some cloud service, if you just want a local database and so on to maybe render nice charts later on. Now, one of the core concepts is that of an item in Eclipse SmartHome, and items are more or less the basic building blocks. So it's a functional abstraction of your surrounding, more or less. So it's important that we're not talking about devices specifically here or any real hardware, but really just defining things on a logical level. So an item could be, for example, the outside temperature. And this is, for me, as an application, then not relevant whether that comes from a temperature sensor that I mounted somewhere outside in the garden, if that's maybe the Yahoo Weather Service or whoever provides that data. It's from application point of view, it's really just a number item with a value, and that's it. For items, there are 2 main kinds of events. Ones are commands, you tell something should happen. Others are status updates, like for sensors, where you are actually told that something has changed in your environment. Now, based on these items and events, you can more or less build all your user interfaces, your automation logic, You can define what should be persisted about that. And on this level, which I like to call usually the virtual level, it's really all your model. It's not connected to any kind of hardware. It's not hardware specific at all. So you can really build and model your system on that level. Now the connection to the real hardware is done, as I said, through so-called bindings, which are more or less simple translators then between the abstract events on the event bus and a specific protocol or device, however you can access that, whether that's through a USB dongle, through IP, through some REST interface, or whatever. Now for openHAB, there is a very large developer community building bindings for all kinds of systems. So this is just about 50 of them. I think we're now at around 100 different bindings. So almost anything you know around smart home should be covered by that. So it's really amazingly large set. But as openHAB was so far targeted at developers, at tech-savvy people, all the setup is done there in textual configuration files. And this is just an example. You usually look up the wiki page of the binding, get some explanation of how you configure what, to say for this item that's now connected to my physical device. That's an example for KNX, a rather complex device, just to show you that for an average user that might not be very nice to set up. Now, that is one main part that is currently addressed in Eclipse SmartHome, where most development is done. Because once for openHAB, the growing community of users, there are more and more average users which are not developers, but who like really the functionality and would like to use it. And for a company like Deutsche Telekom, of course, you can imagine that we would never sell a product where the end customer would have to go into VI and edit some configuration files. So KiwiCon is definitely targeted at the mass market for normal users, not like people like us. So what do we need to do there? Well, we changed the APIs for the bindings and the way they have to be implemented so that they more formally describe the devices that they can integrate, so that based on this formal description you can render nice user interfaces, have configuration UIs and so on, that you discover them automatically whenever this is possible, and things like that. So these were the new concepts, and yeah, openHAB, the new version, version 2 of openHAB, uses these APIs now from Eclipse SmartHome to do that. One of the new concepts that has been introduced by that is that of a thing, and a thing is more or less now the representation of a device here. As I said, the thing that needs to be described, although we do not constrain that to devices, but it could be also, for example, a web service that provides some information and data. So it could be any source of information or destination for commands. Now, a thing simply consists out of different channels, and the channels are of a granularity that you can link them to an item. So these are more or less the functions that a device offers, and you in your system can then decide which functionality you want to use. There can be more complex setups where you can't directly access the things, but you need to go through some IP interface, for example, which first has to be configured in order to reach the things behind that interface. So for that, there's also a bridge, which is a special form of a thing. And also, if you think of an electrical cabinet, you might have things installed there which are, I don't know, 10-channel actuators for switching lights in all your house. So the one thing could have very complex subsections, and for that we also introduced so-called channel groups. Okay, enough of the talking. You've seen that I've brought here a lot of hardware with me, so I want to to show you some things live. Where's the camera? Now you see yourself. Very good. So just to show you what I brought here. One is more or less the starting example here. It's a smart plug from Belkin Wemo. Autofocus not working. So on here you can simply switch it on and off, and this old-fashioned light here is attached to that. Okay. Another thing is this LED light bulb here. It's a startup company called LiveX. So that's not just LED, it's also color, and it's Wi-Fi enabled, so that directly hooks up to your Wi-Fi. Then I brought a Sonos speaker system here, which is also on the network, as you can see, and yeah, can stream music there, and which is a very nice device to do kinds of notifications in your house where you might not have your smartphone with you, and so on. Okay, so this is what I have here, and let me go into the IDE. Now, usually openHAB itself comes as a zip file which you extract, run a start script, and that's it. I'm just now running it here from within the IDE, which does exactly the same. And yeah, so all the demo, the setup I did here is using openHAB 2 and running directly here on my local machine. That's a nice thing about Java. I can run it on Raspberry Pi as well as on my Mac here for demo purposes. Okay, once this is started, we can open a browser on localhost port 8080. Jetty is started there, and that welcomes us with a dashboard to point to the different user interfaces that exist. And I'd like to show for the demo the very latest paper UI, which is using material design and which has already implemented now all the setup and configuration aspects of the UI. Okay, we're starting here. We can check in the configuration the bindings that are installed here. So we see we have the Sonos, the LiveX, the Wemo stuff are installed. If we click here on more, we directly see what kind of things this binding supports. And going to the setup wizard, we can search. And actually there are two things directly on our list here, because Sonos and Wemo are both announcing their existence through UPnP. So that has been automatically directly discovered when starting up. LiveX hasn't been discovered, well, because I completely powered it off, so that's not really fair to it. If I turn that on, it now also boots up, connects to the Wi-Fi, and LiveX uses a proprietary UDP protocol to do all kinds of stuff there. So that's something very special. But we see it automatically discovered now here, appeared in the list as unknown for the moment. And all we have to do now is to say, well, okay, these things have been discovered, so we would like to use them in our setup. We can give it a name. Let's call this thing simply speaker. The LiveX, let's call it light. And the switch, call it, I don't know, plug switch, however. Okay. So in the configuration, we can now see that we have these three things in our system are defined. We can click here, see what kind of channels it provides and which are activated, seeing through this white circle. There are even then more advanced channels available that could be activated. And going to the control interface, we directly have all them available, and I should be able to control them right away here. Wonderful. I can switch the light on and off. Okay. So, and if I change here the volume. I also see the slider moving and updating now also the album. Let me try if that works. If I play here. Oh yeah, good. Just to show you now, same on a smartphone. So here for openHAB, there is a native Android application available as well. If I open that, I directly see now myself in the mirror. The same devices are in here, so we can go for the light that we defined. And let me quickly move that a bit to the side so that you can see it both here. Check that bottom. Okay. So if I'm now changing the color right here, you see also instantly the other UI control being updated. So that's nicely synchronized. Okay, and once added, all available in the different UIs. Okay, now I'd like to go to the textual representation to show you what you can now do for automating things and how this is linked to that. For doing textual configuration, like it was in the old openHAB as well, you have an Eclipse Rcp application available that does more or less provide you all nice IDE aspects like content completion, syntax checking, and so on. So I can simply do a control space here and can now decide what kind of item I would like to define. I'm defining a switch for my presence, for example. Give it a label called home. And just by defining that here, we should now see in the UI. Let me reload that. Make it a bit bigger. I missed one important part. I'm also having to associate or assign it to the group all, because here you can define groups, all exists by default, and in the control, this tab shows all devices in this group. And now you see that directly appeared here, so we have a switch with the label home. It's not connected to any device and so on, because we might not actually want to use any physical device to detect whether we're home or not, because usually that doesn't work, whatever you try out. So best thing is really to manually set you're home, you're not home, and do something with that. Okay, so we have that available now for the other things like the light, for example. Wait, we have to define the item type, light, and then you can bind it to a channel of a device in here. So for that, we can go into the configuration things, our light, and this is a unique ID, technical identifier for this channel of this device. So we can bind that in here. Same I'll do for the power value of the Vimo, the plug, the current power, and for dimmer for the volume of the Sonos. Now that doing that manually here might appear a bit cumbersome, but you could also imagine that in future UIs could be done there to more easily define a technical idea how to use that later on. So here's the volume. Okay, but by this definition now I have light, power, volume defined as keywords that I can use in textual representation for scripting rules and so on, and which are first as a keyword independent of any device. So I can at any time define that maybe I throw away the switch and buy another one which has a different ID then. I just have to replace the binding information here. right, while not having to touch anything about my rules. That's the good thing for the separation. Now, oops, what is that? No, not there. As a rule, I just want to do a use case from a friend of mine, actually, who says, well, imagine this is a socket that you have outside on your terrace, and you usually use it for lighting your terrace, and you might also want to do that while you're not at home. But if some burglar comes along with his power drill, imagine that's a power drill, it's the most dangerous device for burglars, then he shouldn't be able to use that on that socket. Well, you can easily check how much power it takes, and you can do some alarm with that. So let's create a rule for that. It's a template. Let's just call it alarm, and we say when some state changes, that of our item power, then if presence is off, so we're not at home, but the power is more than, let's say, 15 watts in that case, we can use our, oops, no, not JavaFX, don't. We can send a command to our light, which is a U saturation brightness value. U0 means red, full saturation, full brightness, please. We set our volume to 90%, let's say, and we can also use here text to speech and say something. Well, let's see if that works. So, first of all, we need to be not at home anymore. So all is fine. We see the power value is around 6 watts. Our terrace light is on. And now comes the burglar. And there we go. Let's see. Power 24 watts, and it doesn't do anything. Okay, that's a typical demo effect. That had to happen. Actually, I was so happy that I already have a power value here, because when I practiced yesterday, I noticed that this damn plug here, if it doesn't get an internet connection, it always shows power 0. Nothing else. I have no clue why. Sounds like some kind of firmware bug to me. So anybody can spot the problem in my rule. I have light. It's not saved. I think I didn't save it. Refreshing demo rules. Okay, let's see if that works better now. Give me a second chance. So, home, not at home, and burglar alarm. Power, power, power. Go! I don't know what's happening there. That's probably the JavaFX effects. Because I now imported somehow the light here. Presence and power state is more than 15. That's all right. Well, let me try some other use case then. In the hope that the... Why is this here? Maybe that this is red causes a problem. I don't know. Okay, let me try another one, which should be happening more often, because yeah, having burglars shouldn't be the standard case. But yeah, very common thing is that you forgot your light when you're leaving your house, right? So actually, it would be nice to be reminded if you did so. So, pardon me? Yes, yes, you can. The easiest way is through logging statements in there. To do that, right in here, the designer, it's not a step debugger, because it's all script interpreted here. And yeah, the runtime really usually works on a different machine than where you're editing the files. So let's say if our presence changes to off, so we're not at home anymore, then if our light, and now as I said, the light has a state usually which is a color value, but we're now only interested in its on-off status. So I do a get state as. If this is off, on, we left the light on, right? Then, well, please turn it off for us and remind us that the light is still on. So, just in case this rule causes any problem, I delete that. Now, very, very, yeah, convenient it's not to open a smartphone application to switch whether you're home or not. But for this, there's actually some very nice functionality also built into the native Android application, which is NFC support. And right here on the speaker, you see an NFC tag that I put there. And this is actually programmed to simply say, well, it should toggle the presence item to on or off. So having something that next to your door at home makes it very easy to signal your home, whether or not you're at home. Now, let's maybe also play some music again. And the nice thing about NFC is, let me see if we're at home right now. Let's say we are home. Good thing about NFC support is you don't really have to launch the application. You're just holding the phone now next here.
You have left a light on.
Okay, I hope you heard it. This rule worked. Thanks. So using NFC is actually very convenient because it's also much cheaper than any wall switches that you might be able to attach to the wall, but it's also automatically secured because it will only work with your phone, which is already authenticated against your openHAB instance, right? So you could use that simply outside in the garage to open the garage door, to switch a garden socket on and off by holding it next, and also using it at your front door to open that. So, yeah. Let me reload. Maybe it was. Yeah. I know why. Because that sent just a command that I want to be not at home, and nobody set the status. So internally, there is a technical binding that you can activate that automatically, when receiving a command, says, "Well, okay, let's also set the status of that thing," and this is not running here in that case. But usually you're right, when receiving a command that should directly be represented in the UI as well. It's a flaw in my demo setup, I have to admit. Okay. Now some fun part, which is also maybe not too realistic for a home, but I brought another nice device which I mounted up here. You might have seen that, Leap Motion, a gesture controller. You see some infrared LEDs flickering here. In between, there is a stereo camera. So that thing actually records everything above here. and can track my gestures. Let me show you the visualizer just to give you an impression how powerful this thing is. So if I'm holding my hand here, we can see it moving all the single fingers, even with two hands that works, and pretty fast and smooth, right? So I didn't program that application, that's really fun. But what we can do here is to go into our designer and now simply say for our light, we not only want to connect that to the LiveX bulb, but also to our Leap Motion controller. Okay. And if I'm now holding my hand here, we see it's automatically moving. I can adjust the brightness up and down. I can rotate here and choose the color, forward and backward again. I can simply tap to turn it on and off. And it's really fun to play with that. Actually, what makes it even nicer if you do the same for the volume. Let me just starting the music again. And now let's see if that works. Okay. So we see the volume is now also directly in sync. And that's really fun, I can tell you. Changing. No. Come on. Changing the color still works. Yeah. Good. So really cool on a party if you just want to adjust the volume. And so I said that it's just a bit fun and fun part of the demo, but if you imagine that you have such a gesture controller built into your wall switches at home, maybe someday, then you could imagine that you can do some very clever things there, especially for devices like color LEDs and so on. There is nothing really suitable yet that you could build in your wall, and having gesture control could be actually a very convenient thing to do in future. Now, I hope I woke your interest in how you can connect things, how easily you can build stuff then, and so I want to show you how you can actually implement such a binding very easily, or how you get started. I won't show you how to implement a binding, that would take more than the last remaining 7 minutes. But I switch to the console. So here I have a checkout of the openHAB 2 Git repository. I'm just switching to, can you read that? Is that big enough on the screen? I'll do that way. That better? So add-on binding directory. We see there are some bindings inside already and some creation script. So if I'm saying create openHAB binding skeleton, it says, well, I have to provide a binding ID in camel case. Let's do so. Call it cool stuff. So it's a Maven archetype which now generates the project skeleton. It asks for the author. Well, that's me, Kai. Summarizes the settings. Chuck. Okay, build successful. So looking here, it has now created a new folder, org openHAB binding cool stuff. Now we switch into the IDE, import this project right here. What was in this folder? There it is already. Import it, we see it compiles. And most important folder is first the ESH in folder here, which is Eclipse SmartHome information, and this is where you have to describe your stuff, as I said. So here's a thing type description inside, and yeah, there is a sample thing type generated, so we can cool thing 1 define here. Down here we define the channels of the thing, where we have to say what kind of item type it can be associated with, which could be a simple switch in our case. And as a label, get going. So that's good enough for here. As source code, which is in here, you find some constant class, not really interesting, some handler factory, which is a default, which also you don't have to care too much about. And most important class, the cool stuff handler now, and this is a thing handler, and the thing handler means that's the class that really does the translation and which holds your code. So in here you have the method handle command, and you're passed some information. So if I'm now simply putting a breakpoint in here and start in debug mode, make sure our binding, let's deactivate the leap motion, and our new binding here is started on startup. So launching it. UI is not yet there. Okay, there we go. Now configuration bindings, we see our binding is directly listed here with its supported things. And okay, there are no things discovered because there is nothing to discover and we didn't provide any code for that, but we can manually set up now such a thing of this type that we defined. We have to give it a name. We can associate it to some group. Let's put it to the all group as well. Define configuration parameters like an IP address or whatever is needed and say, okay, so this is now added. We see it has the channel get going. This is activated. If we now go to our control UI, we see that it's directly listed there besides all the others. And if we now press on the switch, we end up directly in our debugger in the handle command method. And why doesn't it? Right here. So we see this method has been called as a command. We just received an on for this unique channel ID. So right here, it's now your turn to implement anything in Java that you want to access some cool device that is maybe not yet covered by openHAB, that you want to connect to, that you maybe built yourself, and you can get going. And with that, I'm at the end of my presentation, and thank for your attention. Any questions?
I have a question. How actually this openHAB is bound to the Eclipse SmartHome?
Yeah, let me quickly go back to this slide. So it's Eclipse SmartHome. I usually say it's a framework. It's just a set of OSGI bundles, nothing more. openHAB takes an OSGI runtime, puts the stuff there, has start scripts, configuration around it, puts a Jetty as an HTTP server on top, and so on. So it's really making a full package or a solution that you can directly use and run out of Eclipse SmartHome. That's how you have to think about the relation between the two.
What is the status of openHAB? Is it available for use?
Yes, as I said, it's open source. It's hosted on GitHub, and the version 1 of openHAB, which was actually the starting point for the Eclipse SmartHome project. This is used by very many people. It's stable. You can directly download it and use it. It's just on the level that you have to deal with all the configuration things. So the UI that I showed here with the nice setup processes and so on, that is only part of openHAB version 2, which is currently in alpha stage. Yeah.
And on which hardware you run the openHAB? Because I know for the years on the Raspberry Pi it was quite slow. Java 8 came out.
I think even with Java 8 it's quite slow. So I don't really recommend the Raspberry Pi, but there are many, many users using it. Maybe because they're the mostly available one. It's also directly with Raspberry and having Java already pre-installed, so that's very convenient. I personally run it on old MacBook, which I'm not using anymore, so I have that somewhere in the cupboard at home. But yeah, usually my recommendation would be anything starting with a Beagleborn Black or so, with an ARM A8 processor should be good enough. But in general, everything that runs a decent Java SE version. Okay, no more questions? One?
Do you have any firmware for ESP8266 system on a chip?
Which system, please?
This is a new system on a chip.
Yeah.
It's very cheap. It costs about $3, and we can upload firmware there. It is designed for Internet of Things to implement different sockets, sensors, and so on. Did you work with this?
Does a Java SE run on it?
No, I mean.
You mean to connect to that or
Yes, I
to
mean
integrate
some
with that?
firmware which can connect to openHAB.
Okay, so a binding for such devices. I personally didn't work on that, or it might be that for openHAB 1 somebody is doing integration. I'm not aware of that. Okay, thank you very much.